How's it going? Today we're going to look at 6.4. We've been talking about parallelograms. Now we're going to specifically talk about certain types of parallelograms, rhombuses, rectangles, and squares. All right, some of these shapes you probably know what they are, but let's just talk about kind of like their definition, specifically what property they have. So for a rhombus, you kind of think of it like it's a diamond shape. A rhombus is a parallelogram that has four congruent sides. So all four sides are going to be the same length on a rhombus. And a rectangle is a parallelogram. So to say that means it has all those other properties that we've talked about parallelograms. It has all those properties, plus it has this one more thing. A rectangle has four right angles. Okay? And then a square is a parallelogram with four congruent sides and four right angles. So it kind of combines the rhombus and rectangle. In fact, this is kind of what we think of on our parallelograms. You can have a rhombus or you could have a rectangle, but if it happens to have both of those, then that overlaps into a square. So if you're filling out our flow chart as we go, you can see that rhombus and rectangle kind of merge into, or they flow into the square. A square will have all the properties of rhombuses and it will have all the properties of rectangles. Now let's start with rhombuses. Yes, it has all the properties that we previously talked about with parallelograms. So the diagonals bisect each other and opposite sides are parallel. All that still holds true. Plus, the definition tells us that it's going to have four congruent sides. So typically we think that the opposite sides are congruent on a parallelogram. This is even more specific. But then we have these other properties over here that also hold true on a rhombus. Not only do the diagonals bisect each other, like in a parallelogram, they actually end up being perpendicular. So you can look right here, we've got this rhombus with the diagonals put in there. It always ends up being a right angle right here. Okay, the diagonals don't only bisect each other, like in a parallelogram, but they'll end up bisecting the angle. So as this comes up in here, it'll cause this angle 3 and 4 to be the same measurement. 7 and 8, they're going to be the same also. Works on both diagonals. Okay, so those are some additional features of a rhombus. If you're filling out your flowchart, this is what you'd fill it in with. All right, so let's use that and we'll play around here with the rhombus a little bit. It says, what are the measures of the numbered angles in this rhombus? Okay, well, all they gave us was this one right here, this 104. And somehow we're supposed to figure out all the others. Well, here's the thing, is you have to remember that first and foremost, this is a parallelogram. And so I know that opposite angles would be congruent. So this S over here would be a 104 also, which is not as helpful as I'd like it to be. But what kind of triangle do you suppose this is right here? Remember that these two sides are the same, right? Because all four sides are the same. So really, this is going to end up being an isosceles triangle. And in an isosceles triangle, not only are the two sides the same, but their two base angles are the same. So 1 and 3 are going to have to be the same. And it's a triangle, so they have to add up to 180. So you're going to go to your calculator, or maybe you're going to do it in your head. You're going to go 180 minus the 104. What do you have left after you subtract out the 104? Well, you're going to have 76. Now, 76 degrees is left to split evenly between the 1 and the 3. So you take your 76 and divide it by 2 to see what that will get you. And what we're left with then is 38 degrees there and 38 degrees there. Now, that should kind of make sense because, okay, now remember also then that this is a bisector now because it's a rhombus. So that means 4 is 38 degrees and 2 is 38 degrees. Everything's 38 degrees. But remember that the opposite angles in a parallelogram are congruent, so they should end up being the same like that. The other thing you could check, and you might have done this instead of my isosceles triangle thing, because this is ultimately what I kind of first thought I might do, but the consecutive angles in a parallelogram are supposed to be supplementary. So I could have done the 180 minus 104 to get this entire angle, and then split it evenly because of the angle bisector. Would have got the same numbers. Works the same way. Okay, lots of ways to do that. All the numbered angles are 38. All right, we're going to move on to rectangles. Now rectangles again have all the properties of a parallelogram, plus it's going to have 4 right angles. That's the definition of it, 4 right angles. In addition to that, this is kind of a funny little thing. I think that didn't rotate nicely when I stuck it in there. That's supposed to be a congruent sign. The diagonals in a rectangle are going to end up being the same length. They're going to be congruent. That doesn't happen on that rhombus. You can see that one of the diagonals is longer than the other. It doesn't happen on a parallelogram, only on a rectangle. So these diagonals, the entire length of that diagonal is congruent to the entire length of that diagonal. All right, so using that, let's go ahead and solve the problem. If ln is 4x minus 17, that's this entire diagonal, and MO, this entire diagonal, is 2x plus 13, what are the lengths of the diagonals? All right, well, the 2 they gave me are going to have to be congruent, so I'm going to do a little algebra here. Let's set them equal to each other. I'm going to subtract my 2x, and then I'm going to add the 17. Divide by 2. Okay, x is 15. Now, that doesn't answer the question. They want to actually know how long are those diagonals. So I'm going to take that 15 and I can plug it in for x. I could plug it into either one. Ideally, I get the same answer both times. If I put 15 over here, 2 times 15 is 30, plus 13 is 43. So I'd say the diagonals, I abbreviate that diags, equal 43. All right, now looking at this, now that we've talked about rectangles and rhombuses, and then again, the square, it doesn't have anything additional by itself, but it's going to have all those properties of the rhombus and all the properties of the rectangles. Now, it says here, is the parallelogram, so we know that it's a parallelogram, is it also going to be a rhombus, rectangle, or square? All right, so on number 1, we know that it's a parallelogram, so we know opposite sides are congruent. So if this has a single hash mark, so does this. If this has a single hash mark, so does this. Ultimately, that's going to make all of them be the same. That's a rhombus right there. All the sides are congruent. However, it shows me right here that I have a right angle. And again, I know opposite angles are going to be congruent, so this is going to have to be a right angle. Consecutive angles are supplementary. That's going to be a right angle. They're all right angles. Oh, then that's a rectangle. And if it's a rectangle and a rhombus, it is a square. All right, next one, number 2. Okay, just by looking at the picture, I can tell all the sides are congruent. You have to kind of be careful with just trusting their picture, because that first one definitely looked like a square. This definitely looks like a rhombus. Well, it is a rhombus. All the sides are congruent. The 130 degrees is just clarifying, hey, that's not a right angle, which means it's not a rectangle, which means it can't be a square. That's a rhombus. All right, last one. What are the measures of the numbered angles in the rhombus? Okay, we did this earlier. What are the measures of the numbered angles? Okay. It's a rhombus. So I don't have those right angles that a rectangle has. But do you remember that in a rhombus, this diagonal comes in here and bisects the angle? So if this one over here is 50, then this one over here is 50. So I would say the measure of angle 3 is definitely 50. Now I have to work on the other ones. I think what I would do, let's look at number 2. I probably could have started with number 2, because remember that the diagonals are always perpendicular. So this number 2, and they made this a little bit trickier because I don't think that looks like a right angle, but it is. They're supposed to be perpendicular. So I would say the measure of angle 2 is going to be 90, because it's supposed to be a right angle right there. Which also means that if you think about this for a second, and there's a lot of ways to do this problem, but I do vertical angles. This is what just jumps out to me. I got vertical angles here. So, well, and regardless of the vertical angles, all 4 of these are going to end up right angles because they're perpendicular. So I have a 90-degree angle here. And I just found out that the 3 was 50 degrees. And I know that these have to add up to 180 because it's got a little triangle here. So a 90 and a 50 and this would have to be 40. That way they'd add up to 180. All right, so measure of angle 1, kind of did those all backwards. Measure of angle 1 would have to equal 40. All right, a little practice with algebra. They didn't give us a picture this time, so don't be afraid to have to draw a picture, because it's going to be important when they tell you JKLM is a rectangle. Where is J in reference to K to L to M? So draw the picture. Because here's the thing, it doesn't really matter where you start, but you do have to wrap around the figure with those letters. So if you decide to start J right here, and it doesn't even matter which direction you wrap around, but just go J, and then the next one's K, and then L, and then M. Because it's important to recognize when they say JL, is that one of the sides? Or you can see JL is actually a diagonal. So as long as you wrap around that rectangle in the order that it's given, then you can designate it as a side or a diagonal. So JL, 4x minus 12, MK is the other diagonal. And what do we know about the diagonals? They're supposed to be congruent. Okay, only in a rectangle and a square. But you got your diagonals congruent. So this is just like our last problem. 4x minus 12 equals x. Whenever you have an algebra problem here where the only thing you have on one side is, like in this case, I just have an x, don't move that. That x has to stay put. We don't want to get everything over on one side. We want to make sure you got something on both sides. So as much as I would like to go the other way here, I'm going to go ahead and subtract the 4x. It's going to be okay because that's going to be a negative 12 sitting there. A negative 3x, and that's going to divide just fine. X is going to equal 4. And it says, what's the measure of each diagonal? Well, the diagonal is x, so it would be 4. If you plugged it into the other one, you should get the same thing. All right, so the rest of this is going to be constructions. And again, I'm going to just kind of freehand my constructions. You can do this in your construction notes. We're going to construct a rhombus. Okay, this is actually a pretty easy little construction because we're going to make all 4 sides congruent. We did this with a parallelogram, but we had to make the opposite sides congruent, but they were going to be different from each other. So in this case, I'm only going to have one measurement. I'm going to start off, just going to draw this random line here, and I'm just going to pick how long do I want to make my sides. I don't know. Put the point of my compass right here. I'm just going to put an arc right there. That's how long I'm going to have all the sides. And then I get to randomly pick this, put in this line in here, and I'm just going to make sure then all the sides are this same measurement that I did on the first one. So if I'm going to do that, then I'm going to put the point of my compass back here. I'm going to do it up here, same measurement. Okay, from right here, I'm going to do it out here someplace, and that same measurement. From right here, I'm going to do the same thing. I'm going to get this X shape out here, and that's going to be the other vertex on my rhombus. It's a quick, easy little construction. It'll force all 4 sides to be the same. All right, let's try constructing a rectangle. We're going to make a right angle, and then we're going to do opposite sides congruent. All right, so starting off. Now, the right angle is going to be the perpendicular bisector construction, so you're going to want to make sure that you make this plenty long. And what I'm going to do is I'm going to go ahead and I'm going to pick a spot, let's say right here, and I'm going to do that construction through a point on the line. So I kind of came out here enough that I have some space to work on either side of that. And I'm going to do that construction where you put the point of your compass here, arcs on either side. And from those 2 arcs, I'm going to do my arc. Remember, stretch it over halfway, arcs above and below. Put the point of your compass here, arcs above and below. Now I'm just running through this. You probably need to pause the video as you're constructing and then wait on, get caught up. All right, so what I've got here then is I'm going to have my right angle that I want. Right here is going to be the right angle. Now I'm going to make opposite sides congruent. All right, and this is kind of random. You can use existing measurements that your compass is already set at, or you can do something different. I'm just going to open my compass up randomly, point of my compass here, and I'm going to say, oh, I want this leg to be this long. I want it to be really long, okay? Now, then I'm going to randomly pick some spot up here, doesn't really matter where, put the point of my compass here, and put that arc out here. Same measurement. Now I made those opposite sides congruent. One set. Now I have to make the other set the same. So I'm going to put the point of my compass. I had randomly picked this measurement, but I need to know how long that is. So measure this out. How far is it from the point to that? And then you're going to come over here and transfer that measurement right there. Now you've made that set of opposite sides congruent. And you got that X that you can create your rectangle with. And you've got your one right angle, which is really going to force all the angles to be right angles. And you've got your opposite sides congruent. All right, last construction. We're going to construct a square this time by making a right angle and 4 congruent sides. All right, super similar construction. It's just I'm not going to change my compass to measure 2 lengths. It'll all be the same length. So I'm going to start off again. Line plenty long. Put a point somewhere in here. Arcs on both sides. Stretch your compass up over halfway. Arcs above and below. Compass on the other side. Arcs above. Oops, that goofed it up. Arcs above and below. And that's your right angle. And then it says you're going to make all 4 sides congruent. So you get to pick some random measurement. How big do you want to make this square? And put the point of your compass here. I'm going to make it go to there, just random. But if I want that side to be that long, then I'm going to make this side up here be that same length. And then from here, I'm going to go that same length, never changing my compass every time. Got that X out there. Now I've got a point to make my compass. All 4 sides were that same measurement. Okay, not too bad of constructions today. All right, hope this helps. Good luck.